All right. Well, welcome to December's lessons. Okay, here we go. So we have 5 goals this week, and I know that seems like a lot, but a lot of them just kind of build on each other, so it'll be okay. So our first goal is to be able to classify triangles by their sides and angles. Second is to be able to use triangle sum theorem to find a missing angle measure. Then we're going to be able to use triangle sum with algebra. Then we're going to use exterior angles sum to find missing angle measures, and then we're going to use exterior angles theorem to set up and solve with algebra. So let's start with our triangle classifications. There are 2 ways to classify triangles. You can classify by sides and by angles. So first one we have is classification by sides, and we have 3 side classifications: scalene, isosceles, and equilateral. And it's all about the number of sides that are the same. So for scalene, we have no equal sides. So this is whenever all 3 of your sides are different lengths. They're considered scalene. Isosceles, when we have 2 equal sides. So if 2 of the sides are the same, it's considered isosceles. Equilateral is when we have all 3 equal sides. So in your triangle, if all 3 sides are the same, it's considered equilateral. So those are your 3 classifications for sides. No equal, scalene. 2 equal, isosceles. 3 equal, equilateral. All 3 of these vocab words will be on your exam. All right, here we go. Now, our angle classifications. There are 4 of them: acute, obtuse, right, and equiangular. 3 of these you've heard before: acute, obtuse, and right. So you might be thinking, okay, acute less than 90, obtuse greater than 90, right equal to 90. Those are angle classifications. We're talking about triangle classifications here. So they're a little different. For acute, it means we have 3 acute angles. So if you look inside your triangle and all 3 angles are less than 90, it is considered acute. Obtuse, when you have 1 obtuse angle. Okay? So if you look in your triangle and you have 1 angle that's greater than 90, it's considered obtuse triangle. A right triangle, when you have 1 90-degree angle. So when you have 1 right angle, it is considered a right triangle. A lot of them are going to look the same. They'll look something like this with a box. Those are right triangles. An equiangular, this is whenever you have 3 equal angles. Now, just to let you know, a lot of students get acute and equiangular mixed up. Because technically, if it's equiangular, all the angles are less than 90. But remember, if they're all less than 90, but they're all the same, it is equiangular. But if they're all less than 90 and they're not the same, it is acute. So let's practice classifying triangles by its angles and sides. So let's start with its angles. So let's look to see what is happening with our angles. So I notice we have a 57-degree, a 79-degree, and a 44-degree. Well, they're not the same, so it's not equiangular. One of them is not 90, so it's not a right. None of them are greater than 90, so it's not obtuse. All 3 of them are less than 90, so our first classification for angles is acute. All right, now let's talk about our sides. Remember, sides is all about however many are equal. So we have a side that is 5.6, one that is 6.8, and one that is 8. Are any of those equal? No, none of them are equal. Remember, if none of them are equal, then it is considered scalene. So if I asked you to classify this triangle, your final answer would be that it is an acute scalene triangle. So make sure you have your vocab out and handy whenever you're doing your homework so that you can easily see which of the classifications match up with which. All right, goal 2. The triangle sum and missing angle measures. So what exactly is our triangle sum? So the triangle sum is talking about what happens inside our triangle. So inside this triangle, we have angle A, angle B, and angle C. And our triangle sum theorem tells us something very special about these three angles. That no matter what they are, if they're inside a triangle, they're always going to add to equal 180 degrees. So just remember that the inside of your triangle is always 180, no matter what, okay? No matter what type of triangle it is, the inside is always 180. So let's practice. Let's look at this example. We want to find the missing angle measure. Here's the angle measure we don't know. Oh, sad day. If you're better with like variables than you are question marks, let's go ahead and turn this into an x. It's something we don't know. Well, we know that a triangle equals 180, so we can add all three of these to equal 180. We can say x plus 87 plus 36 equals 180. Then all it's about is combining like terms and solving for x. So we have like terms right here. Please use calculators. They were created to assist us, so let's use them. So we end up with x plus 123 equals 180. All right, let's subtract 123 from both sides. And we get that our unknown angle measure is 57. Yay! All right, you will have questions like this on your homework. It'll be multiple choice. All right, moving on to goal 3. We're talking about triangle sums some more, but this time with some algebra. No matter what you have happening inside your triangle, the same will always be true. The inside equals 180, forever and for always, okay? So let's see what we're dealing with here. We have 41 plus 72 plus x plus 78 equals 180. All right. Again, this is all about combining like terms and solving for x. So we're going to take 41 plus 72 plus 78, and I get x plus 191 equals 180. Okay? We're going to subtract 191 to get x by itself. We get the value of x is a negative 11. Okay? You'll have questions like this on your assignment too. Again, there'll be multiple choice, so it'll be okay. All right. Our last theorem we're going to talk about is the exterior angles theorem and missing angles. So the exterior angles theorem is dealing with the special angle that ends up being on the outside of our triangle. Okay? This angle does something special. That outside angle, let's call it angle 1. Or actually, I can make it 2 easier. Let's call it angle 2. All right? Angle 2 is always going to be equal to the two inside angles that do not touch it. See how this inside angle is touching 2? Well, this one here and this one here are not. So I like to circle them. I do arcs for outside, circles for insides. So angle 2 is equal to angle A plus angle B. Forever and for always. The outside is equal to the two inside added together. So let's use that information to solve for a missing angle measure. So here's the angle we want to know, this one right here. Ta-ta-da-ta! So the next thing you need to do is determine who is outside. So we have x, 60, and 112. Which one is outside of our triangle? That would be 112. This is the exterior angle. And we know that our outside, 112, is equal to our inside added together, x plus 60. Okay? Now, sometimes your x is going to be on the outside, just to let you know. Just remember, outside is equal to the inside added together. So we want to solve for x. So we're going to subtract 60 from both sides. And our final answer is 112 minus 60. And that gives us 52. Ta-da! All right. One more example, and then we are done for this week. Let's talk about if we're dealing with algebra in that exterior angle. Again, it is important to remember, let's identify our outside first. So the outside is the one outside of our triangle. So our outside here, it looks like it's 1 plus 26 x. And it is equal to our insides added together. So I'm going to circle my inside. So I've got 35 plus 16x plus 6. All right, when I see problems like this is where I like to draw my line and do my variables and constants. Okay, so my variables, so I have a 26x and I have a positive 16x, but I got to move it over here, so now it turns opposite. All right, my constants, I have a 35 already over here, plus 6 already over here, but I have this 1 I need to move over, so minus 1. All right, so what is 26x minus 16x? I do believe that is 10x. All right, then we have 35 plus 6 minus 1. That gives us 40. All right, let's solve for x. We're going to divide by 10 to get x by itself, and we get our answer as x equals 4. Again, the problems that I do for your examples on your notes are problems that are actually on your homework assignment, so you already have a few answers to help you out. Make sure you watch the video again if you're struggling with the concept. If you have any questions, please send me a remind message. I get those a lot faster than I do Google Classroom messages. And do not forget to take a picture of these notes and submit them on Google Classroom. Thanks, guys. Have a wonderful week. Don't forget to do assignment 2.